Welcome, everybody, to this year's presentation at SDC 2022 at the virtual conference. My name is Ralph Boehme. I'm a longtime member of the Samba team, and I work for SerNet in Germany. I'm one of the core engineers on the file server in the Samba project. I do a lot of bug fixing, feature development, working with customers on enhancements, on customer-specific VFS modules, and so on. And in this year's presentation, I would like to give a brief overview of recent improvements that we have achieved in the last 12 months, roughly, recent changes and improvements, and subsequently I will try to give an outlook into what's in the pipeline, what is coming, and what are features that we are currently working on, that we are designing. What can you expect? What improvements can you expect in Samba in the next years to hit your door? So to get started, a quick outline. As said, I'm going to start with just a brief recap of recent changes. And then I will start with an overview of what's up our sleeves. And that will be basically three parts. Features that are kind of work in progress, where a Samba team member or anyone else is working on an improvement on a feature actively, and we can actually see and expect progress in a reasonable foreseeable future. And then there is a large list of prototypes that Samba team members have been working on in the past years, including myself and other colleagues here from the team, where there haven't actually been a lot of progress in recent years. And I will try to give an overview of the status of all those individual larger projects, and give a quick introduction of why they are stalled and what are the challenges and what's needed to move on there. And then finally, there are also a few interesting ideas for improvements where we are basically at the design stage and are still thinking about what could be done for certain things like performance improvements and so on. More on that when we get to the slides later on. All right, so let's dive into it with the recent changes in SMBD. And also, let's start a timer, although it's probably a bit late, so let's go on. So, one of the biggest changes that have been done in the last 12 months is probably security related and related to changes, big changes that we've done in the Samba virtual file system layer. All this was needed to actually fix a security issue that was discovered many years ago, and that took us a very long time to fix. Pointing out Samba team members, Jeremy Allison, Samuel Cabrero, No Power from Susie, and also myself did a lot of work here over the years to work on this security problem here, and finally be able to ship the fixes as a major release last year, I believe, end of last year with Samba 4.15. So that was a major effort, and all this was about dealing basically with symlinks and avoiding security problems there. And Jeremy and Volker, Samba team colleague members, gave very detailed, insightful presentations on the matter 2 weeks ago, roughly, at this year's Samba XP. So if you're interested in more details about this, I can highly recommend the presentations from Jeremy and Volker from Samba XP. And finally, these fixes for the security issue caused a performance regression. And this is something that's currently being worked on. More on that on a later slide. And Volker gave also a presentation at Samba XP, which will go much more into detail there. So another thing that we shipped recently as part of a new Samba release was a completely new infrastructure and processing model for RPC. We now have a separate process where all the RPC processing is done, and basically processes like SMBD, the file server that accepts RPC requests over SMB, for example, on named clients from clients, just forward those RPC blobs to the Samba DC RPCD process that is now responsible for processing the requests. And this allows us some interesting changes in the future. Possibly something like using kernel KSMBD file server process instead of SMBD. And yeah, that's going to be, that gives us interesting opportunities. We'll see. I have a slide coming on later where I'm going to say a little bit more about that then as well. So what's next? SMB1 is on the way out now since a few years. It's disabled by default, and now we recently we got the possibility to basically completely remove SMB1 support and drop it completely from the build with a configure option with SMB1 server. It's still enabled by default, and but you can then pass without SMB1 server to really completely drop all the code from the binary. Other noteworthy changes include some great cleanup and reduction of code. Actually, previously in older Samba versions, we had 2 full RPC server implementations, and recently this got merged to basically only having 1 RPC server code base that is used both in the ADDC and in the file server. And as part of that, the RPC server used in the file server acquired support for async RPC, which is needed for certain RPC services. So this had been a blocker in the past for adding witness support for the file server, which is part of the clustering features in Windows. And now that we have async RPC support, we can finally, this is finally unblocked and we can move forward there. Next change, SMB3 multi-channel is no longer experimental, so that's great. Uptime, Heimdall got a pretty big update. This is something that hugely affects the ADDC, not so much the file server, but it adds a few interesting features like Kerberos fast support, which is also useful when file server when being Kerberos client. We got certificate auto-enrollment via GPOs, which is eventually useful on file servers as well. Trusted domains are no longer scanned and bin-bind, and this is a subtle but pretty important change, as it brings us in a much better position, being fully compatible with Windows in large Active Directory domains and behaving like Windows when being a member and talking to domain controllers for authentication and authorization information and doing RPC. And finally, here on the list, support for offline domain join. I've heard that it doesn't seem to work quite the way that one might hope it would be. The user interface seems to be a bit dodgy, but in best Samba tradition, we can build on top of what we have and improve incrementally. So moving on, now we're going to see the big list that I've prepared here of all the precious features that that we have been working on, that we have prototypes for, and that we're still designing. So let's start with the work in progress stuff. And that's the file server performance regression that was basically caused by the symlink race security problems mentioned initially. And the thing is that this also caused quite a performance regression that affected Samba releases for 4.14 and newer. And the interesting bit is that Samba has an option, white links. It defaults to no, which is meant to tell Samba that security checks should be done on symlinks and ensure that symlinks are not pointing outside the configured share. And one might think that setting white links to yes would also prevent the expensive checks that we are doing to mitigate the symlink race security performance regression. But it turns out that it doesn't help because the expensive checks are still done. It's just that the result is then basically not used. And so the performance regression is mostly noticeable probably on fuse-based file systems or on virtual VFS module-based file system like ClusterFS. I did some benchmarking here on local ButterFS file system, and as you can see, let's see, is my mouse. There it is. Okay. As you can see that in 4.13, taken as baseline, it takes me 70 seconds to do an rsync of a Samba extracted Samba tarball onto an SMB mount from a Samba server. And so with 4.15 and 4.16, there's a decent regression there. It's 2 seconds slower. And so we already have some improvements here in newer Samba versions. So master, which would be next version 4.17. But there's actually more to do. And so on file system like fuse-based file system, it seems that we are still slower compared to the baseline version 4.13. So this is something that is being worked on currently by my colleague Volker Lendeke. But this is really highly file system dependent, so I really like to encourage here participation of vendors, interesters, and distributions, and anyone who has any interest here to work with us to ensure that the file server performance gets in good shape again. For a lot of details on this, see Volker's talk from Samba XP 22 2 weeks ago. So next feature on our list, where we have some prototype, is SMB3 Unix extensions. So SMB3 without Unix extensions, it's great feature set, wide deployment. excellent performance. It had SMB Direct. It doesn't have PNFS counterpart in SMB. And the problem is it lacks the Unix features like the Unix extensions that we had in SMB1. So it's not really usable as a full replacement for NFS for Linux to Linux file sharing. Which means NFS is catching up with feature-wise, like for example, it has its own directory releases that we have in SMB3, but it's still the de facto standard here for Linux to Linux mounting. And so SMB3 Unix extensions are really, really needed here as a key feature to bring Samba into a good position to make more inroads into the data center where NFS is used heavily and SMB can't be used due to lack of SMB Unix extensions. And also for persistent storage, for containers, for Linux containers and cloud infrastructure, we need the Unix extensions. And so some work has been done on this in the past. There are some whip branches from Jeremy Allison and Volker Lenneke. Client library is still incomplete, which is badly needed really in order for testing the feature and writing our CI tests. There's also some ongoing discussions to how to change the core path processing function that we have that is responsible for catching symlinks in the path. So yeah, occasionally some team member kicks the code around and works a bit on it, but it's not really currently actively being worked on. It's kind of a low-hanging fruit. Maybe weeks, not months, or maybe a month, but not 4 months or 6 months. So it should be doable with some decent funding, but currently we don't get any user vendor or distro funding that gets anyone to really actively work on this. So I expect some slow progress on this in total. So more on the prototypes. So Splice support for IOU-ring. What is IOU-ring? IOU-ring is a new scalable AIO user space API on Linux. Oh, there's a typo, sorry. User space API on Linux. The use case is high performance file serving. And Samba already has some support. There's a VFS module that you can use with Samba to make use of IOU-ring for IO. And that's quite good. I think it's a slight improvement over traditional p-read, p-write. I'm not sure if it's improvement if you configure Samba to use send file. Samba has support for using send file. I think receive file support is there as well, but I think that is broken. I'm not 100% sure. But the interesting bit really is here additional changes to the IOU-ring VFS module in Samba. And the interesting bit is that we could actually use Splice and send message with IOU-ring, which would give us not completely, but at least avoid a lot of the buffer IO buffer copying that happens with p-read, p-write. And Stefan Metzmacher, my colleague, has a prototype that implements this, supporting and using Splice and send message in the IOU-ring VFS module. And with that, we were able to achieve on a simple test with 5 client connections on a simple laptop connected over a local host connected to the same Samba server running on the same system. We got 35 gigabytes per second. I'm not sure what the bottleneck was, if it was the CPU was saturated. I think it was probably CPU at that point because the clients were using more CPU than expected. And so client and server combined running on the same system, then of course, then saturated the CPU and we couldn't get more than 35 gigabytes. But on a beefy big server, just running the server, I'd expect you could even get a lot more than that. There's also another issue still in the module, and that is related to memory buffers that are registered with the kernel in the module. And it seems currently it registers a lot of those buffers that are used for I/O and it doesn't free them properly, or they really can't be free. We need a way to limit the number of those. I'm not really familiar with the details. It's just something that has to be taken care of and is still to do. So for me, this is really something, a feature that we should, the sooner we get this, the better. This is really makes Samba fly. So this is really, really brilliant, brilliant improvement here from Meta to add this Splice and send message support. It's kind of a low-hanging fruit, not too much work probably required here, a few weeks maybe. But currently, we are not, so no one is currently really working actively on it. So if you're interested in anyone would like to take this up, that would be great. So next one, this is a clustering feature, locking TDB splitter. This is kind of a special use case thing here. So suppose you have a cluster and you have many clients connecting to the Samba cluster, and all the clients are opening the same file. And this could be something like a phone book exe on the server. And so if those 10,000 clients connect, and there's maybe a 10-second delay between each client, so it would, I mean, that would take probably hours then, but the processing of the individual open in older versions, there was, so there are basically two problems. And the one problem that I'm talking about here is that we are storing the file handle state in our database, and that is NDR coded, and that used to be a real performance sucker. The marshalling with NDR was really slow, especially if you went beyond I don't know, a few hundred opens, and with thousands that took a very long time. So that was improved a few Samba versions ago, but on clustered Samba there remains a problem. And that is, so suppose that those 10,000 clients more or less come into the office at the same time in the morning, and they all try to open this file at the same time. So Samba, the cluster nodes, all receive many requests concurrently on the cluster. And in Samba, this in the end is translated to database locking requests and record migration requests in our distributed locking TDB database, and this migration and fetching of the record from locking TDB, that is the record that is storing the open file handle information, results in the record keeping bouncing across cluster nodes as clients on different nodes are trying to get a hold of the record, and no one then can make any progress because the record just keeps bouncing. And the solution is a quite complex re-architecture of the way of our data model, how we store the file handle information in locking TDB. And in the end, it's a bigger effort for kind of a corner case, but I expect that the resulting semantics may turn out to make a lot of sense actually. And so this is something that is actively being worked on, and so I expect that work likely is going to continue in this area, and we are moving into this direction hopefully soon. So next on our list here is SMB3 directory releases. What are directory releases? Directories allow a client to cache directory contents, it's a supplement or replacement for change notifications. And it gives us reliable cache coherence. And instead of just change notifications without basically a best effort, without really reliable cache coherence. And for example, what improvements does it give us? So when looking, for example, at a home folder workload, a user is just connected to a home share, and so there's no concurrent access to files and directories. You basically get 100% packet reductions of the SMB2 packets that list directories. Of course, effectiveness depends on the workload. For home folder workloads, it's excellent, but with more concurrent access by different clients to shared directories, the caching effectiveness is then, of course, not 100%. I'm reproducing here a few numbers from a presentation from SDC 2010. Packet reduction in the home directory workload. On the right, you see query directory. It really goes down from 97 to 0. I mean, the numbers are a bit screwed here. I mean, it's so 97 is kind of 100% probably, and then goes down badly to 9. So all the numbers are relative to the max of the base case. So for all packets, you see a decent reduction, but for query directory, you go to basically zero packets, or probably just one packet initially to list the directory contents. And here's another graph that is from SDC 2011. And it shows frame reduction for different FSCT benchmarks. And you see the effectiveness is really workload dependent, but for all workloads, you get some decent improvements. So what is the status of directory releases? So we have a basic functional prototype. Not all operations, it's not fully functional yet. So for example, not all operations that should trigger a cache invalidation on the client are fully implemented yet. There are a few special cases that are missing. But apparently those operations aren't actually tested in the Microsoft Windows Protocol suite, because with this basic function type, we are already passing Microsoft Protocol test suite. And then we always have extensive coverage of features in our own Samba CI, and that's still so there's still a lot missing. So we need more test coverage and write a lot more tests here for this feature. So this is not really a huge feature. Probably a few weeks of week remaining. This is currently not being worked on. I don't see anyone is funding this. So if anyone is interested in picking and pushing this forward, that would be great, because I think it's really, really a great and helpful feature. Would help Samba a lot. Next comes SMB3 persistent handles. So what are persistent handles? Key goals. It's a part of the larger continuous availability feature, which encompasses multi-channel, witness, as mentioned earlier, and so on. And this is essentially there in order for server applications like Hyper-V or MS SQL be able to store Hyper-V images or an SQL database on the server, and to expect 100% availability in the case of fatal network disconnects or client or server-side crashes. And it achieves network or server failures that are completely hidden from the application. And this brings then basically persistent handles reliability on par with direct attached storage. The Samba status here is there is a basic prototype that is quite big, some 140 patches that are currently based on an older Samba version. So there's some rebasing has to be done, where I expect a lot of conflicts. There's a lot to do. Tests are missing. There's a lot that also has to be discussed yet in the concrete implementation choices that we've taken here. I gave a long talk about this at Samba XP 2018, and there's currently not really a lot of interest in this feature. It's large. It's a complex beast, so it takes a lot of resources to push this forward. So if anyone is interested here in helping getting Samba continuous availability cluster features to the same level that Windows has now, and other competing commercial SMB products as well, offering since many years, and we are still struggling here because it's really complex stuff, and a lot of work is required. Anyone who can help here and is interested in this, that would help a lot, and please get in touch with us. Witness. So we briefly touched this before. What is Witness? A new RPC service. And it's used in clustering for prompt and explicit notifications about failures in high availability systems. And there's a controlled way of dealing with reconnects instead of detecting failures due to timeouts. So it's basically Witness clients in a cluster connect to the Witness service, and if a node in the cluster dies, then the client is always then connected to a Witness service running on another node, and then the Witness server on the other node that monitors the cluster can then quickly tell the client about problems with the node that the client is using for some other service, and tell him about the node failure, and this helps with speeding up service failover on the client. It's part of the larger continuous availability feature, and it's not strictly required for persistent handles. But we have a prototype here from Samuel Cabero based on work from Günter Deschner. And I expect that eventually, I don't know what the exact state is of the prototype. I think the protocol is not that complex as explained once in a presentation from Günter in previous presentations at Samba XP and SDC, where he presented his prototype. And so I expect that once we really get a grip on working on persistent handles, then development will likely also pick up here on the WitnessRPC service. So moving on to SMB Direct. So SMB Direct is a complex new addition to the SMB protocol. It's about file storage really for the enterprise with minimal CPU utilization and very, very low latency. And it basically works by transporting SMB over RDMA, which is remote direct memory access, and that bypasses the operating system and its protocol stack when doing I/O. So instead of doing that, letting do the kernel in work with a network card with interrupts and so on for do all the processing of getting network packets to the network. This is completely doing transparent and without any CPU involvement, and gives minimal CPU utilization and very low latency. my colleague Stefan Metzmacher has started working on this several years ago without any actual funding, which is really a great achievement that he has been able to achieve a working prototype consisting of several parts. A lot is still to be done. The prototype encompasses a new Linux kernel module, which is actually doing the actual RDMA and SMBD Samba fileserver process running in user space just connects to the kernel module over a socket, and but the kernel module is doing the actual SMB Direct protocol and the RDMA. So we need some decent coordination with Linux kernel developers and discuss the right way of the implementation of the module and also the right way to expose the API to user space. The code is still immature, and for example, also ftrace trace points would be good to have in. We need a standalone test suite. Multi-channel integration is not complete yet. We need integration into Samba CI for automated tests. So there's still a lot to do, and my colleague Stefan gave a presentation on this in 2018 at SDC. That contains a lot more details of this. And yeah, this is really a large beast, similar to persistent handles. So without some decent funding, I don't think we're going to see really progress here. So for anyone here interested in having Samba a screamingly fast file server for enterprise workloads, that would be something we should push for. That would be amazing. Moving on, next, S4U2Self. S4U2Self is kind of a special use case. It's something not really required for a simple file server in an Active Directory domain where users are coming from Active Directory. This is more something that is needed to get a group authorization data, group information from Active Directory if users are authenticating to a system via SSH, and Winbind is configured as user and group provider in SS switch, or also for sudo or NFS3 access and stuff like that. And without S4U2Self, which is a Kerberos feature, Winbind tries to get the group information from Active Directory via a special LDAP request via token groups. And this doesn't always work. And the only reliable solution is using Kerberos S4U2Self. And so this is tricky to implement in Samba. Usage is complex, and it involves using the Kerberos libraries, and the Kerberos libraries, Heimdall and MIT, are both missing important features that we would need to implement this reliably in Winbind. There's an overview on what's missing and what's needed in a presentation from Stefan Metzmacher in Samba XP 2020. It's complex. A lot of coordination needed with MIT and Heimdall. A lot of development still needed. This will be interesting to see how this moves, how this will move along. It would help a lot. It would just be the right thing to do. It would be awesome to have this. It's not really required for many common setups, right? But in order to really work reliably as a Linux system in Active Directory that does more than just SMB sharing, and wants to use Winbind as a authorization provider and providing groups to the system, this is really required. So now coming to a few features where we are kind of at a design stage, just throwing ideas here out for things that would be really, really helpful if we could move forward here. One thing is an interesting performance improvement that we see that could be done in the file server, and it's related to storing the DOS attributes in Samba. The Windows DOS attributes are stored in extended attributes, and this can be painfully slow for users that are sharing fuse-based file systems. Apparently, the get xattr call reading the xattr is taking a lot more time than you would see on your traditional ext4 file system or something like that. So in the past, we had some improvement there to basically parallelize the xattr processing with the pthread pool, but according to customer feedback, the load on the system and the performance, so the load was high and the performance was still leaving something to be desired. The idea here for improvement would be to use the statx syscall and then use the native STX time creation date from the file system, which is these days supported by a few of the default Linux file system. I think ext4 has this, but FS has this, XFS has this. So we could use the creation date from the file system instead of storing it in an extended attribute. And also similarly, we could use the statx no-dump attribute instead of storing this as the mapped archive bit, the DOS archive attributes in an xattr. And by using this approach and conversion of existing extended attributes, we could probably get rid of most default attributes that we have stored in the DOS attributes xattr and could just remove it. And so that would be a nice thing. Also, thinking about the future is, so we have ksmbd recently added to the Linux kernel. ksmbd is the file server. It currently, for example, doesn't have domain support. I don't think you can join it to a domain. It doesn't do a real RPC. It's not RPC capable. And with the recent changes and improvements in Samba, to have Samba DC, so to have the RPC service running in a different binary, that would allow the ksmbd from the kernel to connect to Samba DCRPC for RPC. And yeah, of course, this is something where a lot of research and development would be needed, but that's something really thinking into the future. Finally, SMB NFS interop, just touching this very briefly, very briefly. I'm running out of time, 1 minute left. Ensuring that opblocks leases where you're granting clients the right to cache data doesn't result in data corruptions when the files on the server are accessed via other protocols. And for that, we need kernel support, Linux kernel support, and that is not sufficient currently in the Linux kernel. That goes for opblocks and leases, so for caching and also for share modes. We recently had to drop support for using the kernel API here because it is broken and will be removed from the Linux kernel soon. But this is really something that has been plaguing us for years, and a lot of research and brainstorming coordination with the Linux kernel community would be needed here to move this forward. And then finally, last but not least, CDDB. Stop that. My God, that was my timer. Time is over. CDDB, which way to go? My colleague Martin Schwenke gave an awesome presentation on this. I recommend watching this. That's it. Thanks.